In the previous two videos, we've used a very simple implementation of the artificial neuron. We'll keep using this model in the later videos because it's very simple and it also is capable of any behavior that we want of it. However, there are quite a few variations on this theme which you will see in different books. And we'll have a quick look at some of these so that you can recognize some of the variations which exist when you come across them. But however, do bear in mind that this is not a comprehensive list. One variation that you might find is a constant bias term. This is added to the neuron like a separate input and tends to appear in older implementations of ANDs, particularly with threshold units. The value of the bias is set along with the weights as part of the training or learning algorithm. Changing this bias term as part of the learning has a similar effect to changing the threshold value of the neuron. This is illustrated in the diagrams on the screen. So some training algorithms change the threshold of the neuron while others change the bias term. Adding a bias to a sigmoid type neuron has a similar effect. Other terms can also be added, for example, to change the shape of the activation function. Again, these can be tuned as part of a training process in some of the more complex learning algorithms. And of course, there are many other activation functions to choose from. One example which is used in systems where nonlinear functions are hard to implement, for example in microcontrollers, is a piecewise linear function as shown on the screen. And so, through the decades of experimentation with basic ANDs, dozens of alterations have been tried out. However, as I mentioned before, we'll stick with the simple neuron which I've already illustrated in the last few videos. With modern training algorithms, this unit can perform nearly as well as most of the other variations.